We now finally have some entity framework, which means we can start storing settings in a local database or even a remote if we wanted to. Next up, we want to add the entity framework properly into dependency injection so that we load it when we want. And let's get this settings page fully linked in with that entity framework. So the first thing we're going to do is update this settings data model to now reflect everything on this page that actually needs to be stored as a proper setting. So we'll start by looking at the page and going through. The license we don't currently have yet. We've made this up until we do the whole licensing system, so we can't really add anything there. But we do have this skip files if open, allow duplicate entries, so these two are booleans. Let's start with them. So we'll have public boolean skip files if open, save and close are valid options. So really, what shall we call this? Skip files with basic processing, maybe. It's a bit long. Skip no action files. I think we'll call it that. And that's because this is basically when you're doing a batch job. So any of these actions, sometimes you just have no actions for a specific file. So if a filter says don't process a certain file, and it ends up just being an open, save, and close, so there's nothing to really do, we can optionally skip that file. Allow duplicate entries, so we'll just literally call that one allow duplicate entries. Locations we have, which is here, and that's how we'll store them. Then we have the SolidWorks host IP. Now we could store an IP as an actual IP range, I think it's called. IP address or IP range, whichever, but we're going to keep it flexible and store it as a string, so we can do anything in this drop down that we might want to do in future. We can always parse this after. So we'll call this SolidWorks host IP. And then we have PDM Enterprise, vault name, username, public string, PDME, vault name, username, and password. Now, we have here effectively a password being stored in a database that isn't password protected yet. And it's also not obfuscated in any way. So it brings us to a kind of dilemma where the user's logged into this machine. The code could always be reflected to, have a look and crack software and look at what's going on to see what password's been entered here. You could also hack the database. There's so many ways in which you can't really protect the password when you're logged into a Windows computer because you've already got full access to the machine. So anything you store here locally on this machine in some way can always be accessed. The best we could do with this is probably password protect the SQL database, obfuscate this password, maybe do some kind of, when you're storing it in the database, do a kind of hashing code. So it's a little bit more work for the end user that's just going to try and browse a database, open the file, and sniff at it. It's going to be more work. So we'll save that for another video. But just bear in mind, for now, we'll just store it. But before this goes into any form of production, we'll do something about this. You can also do stuff like a secure string, which doesn't really help us in this context. But as I say, we'll kind of go through this separately. You've got the login, which we'll just log in, refresh vault. Cache isn't settings. This is temporary files, thumbnails, logs, things like that. So this won't be stored in the database. So that now forms our entire settings data model. Typically, if this was already running, so say this is now an active database and we have settings in, which we know we currently do, we have the database here, and although we're not actually adding to it at the minute, if we uncommented this code, we'd end up adding to the database. If we wanted to now properly keep those settings and migrate, because we've changed the data model, so all we've done is edited this class, because we've done that, and because it's stored in here as a DB set, this won't crash because these files are extra. But if we rename this to say locations path 2 and tried to access this now, the database would crash because it doesn't match the actual database. The same way, if we tried to add and save these to the database, it would crash because they no longer exist. So what we have at the minute is the entity framework class in the code behind doesn't match the actual database. And this is where migrations come in. There's two ways of handling this. Because we don't actually use this database yet, I would typically just delete the entire migrations folder and just keep creating the database from fresh until we're ready for migrations. But let's presume this was now a live database and we want to upgrade and add these fields. Right click on Batch Process 3, open in Explorer, And then we want to open inside of this folder. So we'll type command here. And what we can do is do that .NET EF, which is from those entity framework tools we installed. And I believe it is migrations add. And then now we give it a new name. So we'd say settings data model update. And this will now build the project, compare the differences from the initial CS file to where we now are, calculate the differences, and it makes this new class, given the name that we give it, and it now makes the database code that tells it how to upgrade our tables to match, as well as how to downgrade back to the previous version. So you can see that's going to take care of migrating the database and adding these fields. So it's going to add and allow duplicate entries as an integer, a password as text, username as text. And what we'll see is inside of here, so see how you've got an ID text, location path text. This currently, that's all we have. If we now comment out this code, run just the migrations, and comment this back in, we will see that it's going to do those migrations in this file, and our database should get updated. That's it, it's ran. So now let's take a look at the database. If we refresh, oh, we didn't run the code, did we? Because we set this code to run when we enter the actions page. So let's just try that again. So we set it to run when we click here. So there, that took a little bit longer. And now if we go into here and refresh, there we go. So now you can see it's updated the database to have all of the fields that we've just added. So that's the magic of the entity framework side. You don't have to worry about your database too much. As long as you understand what's going on, you apply migrations when you need to, this will work. Now, because this isn't yet in production, and I don't want a bunch of pointless migrations that don't really matter until we hit production, what I'm actually going to do is delete that entire migrations folder. I'm going to delete the actual database, which is in the desktop version, so we can start fresh. And I'm just going to change this code. I know it's temporary, but I'm just going to change this to ensure created for now. And then we'll just put a to do here. This code's going to change anyway, but just so we have it, to do, change to migrations once we start persisting data. So once we start to do anything where we want to keep the data, we'll change this to .migrate. This will now create the database, but it won't add the migrations table. So let me show you the difference. You can see at the minute we have these EF migrations folders, and we have information inside of them. So if we run them, oh, I've deleted the database, so I can't show you what was in them, but you have these tables here that existed. Now if we recreate the database by clicking here, close down, and refresh here, you can see now we just have the settings table and those migration tables have gone. So this doesn't have any migrations applied. So you can't then go from this database to a partial migration. So say we still have those migration files there. You couldn't then just go from ensure created, use this database, and then start trying to apply migrations. It's a lot more difficult. So you're better off only doing this at the start, and as soon as you want to keep data, move to migrations. So now we have the data model ready to store settings. We want to integrate it into this page. Now this page, when it loads, will be through the view model, and the page gets loaded by the view model locator. So we're interested in the settings page view model. And then here you see, once we load in, so this will be when the page pretty much comes into view because this gets newed up. I'm sure every time we go to the page, this is hit up. So let's just test that. So we're hit up there, we navigate out, navigate in. Yeah, so this is our kind of point at which we want to load settings. Because we have dependency injection, we want to inject this dependency here. Now what we want to think about is database calls are not really something you want to persist long term, they are short term. So we definitely want a transient dependency. We want to make sure this is transient and everywhere we use the database is transient. And because there is very likely going to be a point at which one of these services, say the main view model, wants to access the database, that's a singleton. So as soon as a singleton accesses a transient, the transient becomes singleton because this is newed up once. And if we inject the dependency into anywhere, so into, say, the constructor here, as we knew with page factory, it's only ever going to get newed up once. So even if page factory is transient, because it's injected into the view model, it would always be singleton. That's kind of the thing with dependency injection. So because of that, we want to do exactly what we did with the page factory, and we want to make a factory for the database. So we'll call it a database factory. And that's just so that we can guarantee that everywhere that wants to consume the database service, it's always going to just be spun up new and disposed of as soon as done. That's how we want to handle databases. So we'll go to factories, page factory, copy and paste. We'll have a database factory, and this is pretty much verbatim for the page factory. So at the database factory, we want then here, we are returning a view model. Well, now we need a service to actually handle the database services. And this brings us down another architectural question. Do we want to have a global kind of database service, which I think we do, which is something that handles the specific entity framework calls? But then on top of that, we'd have things like maybe a settings service if something wanted to specifically handle just loading settings in, which is probably going to be the settings view model. So we'll want a service called database service, and this will all come together in a moment. You'll see what's going on. And you can see, just like the other services, it'll just do some basic tasks for us. This is going to handle all the entity framework stuff. But importantly, this is the class we want to give back as a transient. This is going to be the thing that spins up every time, does the database calls, and disposes. So this class will want to be iDisposable, because we know we want to handle disposing of the service. And then here we'd have a private. And then if we just go to the place where we have the code, where did we put the code? Here we go. So if we just cut this out, get this back to normal for now. And then our database service, if we just paste this in here for now so we've got somewhere to place it, we know we need this context. So this is what wants to be a transient. So we'll have the underscore context, and this is going to be the database context. This wants to be pulled again from a dependency. So what we'll have here is a constructor. This will now have the application database context, and now we can just assign the context to that. I believe we can then do the shorthand, which moves it up to here, and now that is going to inject the context. And what we'll do is make sure that application DB context is in dependency injection, which it currently isn't. So let's just fix that. Let's add a transient of application database context. We'll want the database service being transient as well. So we will inject that. So now the database service can be fed the application database context, and that's also transient. And then in dispose of, we want to make sure we do underscore context dot dispose. And if this is always created, which it should be, it's never going to be null. That can be marked as read-only correctly because it's going to get instantated once and disposed of when done. We now don't need to do this new because dependency injection does that for us. And we now have a context where we can do anything like ensure created. So now what we want to do is in the constructor, we can paste this in. And because we now have a constructor, we can't do this. So we will now cut that out, paste that in, do underscore context equals context. And in the constructor, we can do the ensure created. So every time we spin up or request the database service, it's going to quickly do a apply migrations. Now, we might not want to do this every time we spin up this service, and I don't think we do. We'll want to do this every time we spin up the application. So we're going to move this out of the constructor. Instead, have a function that someone can invoke and call off us, and call this apply migrations. And then, obviously, we're not applying migrations for now, we're just ensuring created. So when we spin up the application in the app, somewhere maybe here, once we do something, we'll pick a point where we decide that we want to ensure the database is migrated. That means this constructor is back to what could be placed up here. So let's move him back out and up to here. So now we have, if we access the database service, it's going to create a new database context. On dispose, it's going to dispose of it, and we can apply migrations. And there's nothing else we can do at the minute, but we can do what we had before. So let's just now pull some settings so we can actually get the settings data model. And then we can do something useful with this. This, again, is a database service. So this is where I mention, do we potentially want to split this out into other services, not related to everything, but say splitting out. So settings, database services are handled by a separate one, along with actions, macros. But because, again, I don't like to split too much until it's needed, we'll dump everything about the database stuff into this one service for now. So for now, this one's going to handle everything, and we're going to call this get settings. And then here, if we just uncomment what we had, this has got nothing to do with it, but we'll just see. This is creating a new settings, adding, saving, so we don't want that. This is getting, so this would be context.settings.toList. And then we'd remove them and save changes. So in this instance, to get settings, because there should only ever be one setting, and we're kind of going to enforce that, I think, for now, we could either clear the settings to ensure they never accidentally get more than one, otherwise there's going to be issues, or we just always make sure we access the first one. So what we can do is, for now, just access the first one. This is just going to be context.settings.first or default, and it's that simple. That's all we've had to do to ensure that we will now get the settings. And because we have a DB set of settings model, it's saying it can never be null, which doesn't make sense because the database can be null. So it's actually recommending us to change the context to a nullable class. And then that's wanting us to remove it. This is wanting us to add it. I'm not sure which way IntelliSense wants us to go here. So that will now return the first settings always. And this literally, this call here will actually hit up the database as we call it. Expression body, yes. Replace captures. Yeah, I was accessing the wrong one there. I've got to be careful when I'm accessing it. That wanted to be underscore context, not context. So that's the only thing with passing it in the top here. You can actually access it directly in other calls, which you might do by mistake. And then this dispose, I don't know why it's warning about explicitly doing that. Just toggling between the two. I'm not really sure why we've got that little warning there. But that is, I think, the basic database service now done, which we can consume and at least get some settings. So let's close that down, go back to the factory. And now we have here a database service. So that's what we want to return. And it will be database service, and this will be get database service. And then type, we don't have a type. So this is literally just a type. And after creation, we could do something. That also wants to be nullable, apparently. So let's fix that in the one here as well. And now it's not view model, it is database service. After creation, pass in the, we don't need to even pass anything in, we just call factory. And why are we passing in a type? We don't need a type now, do we? We just need the function. And then invoke, we want to pass in, so we have a action of database service. There we go. Spell that correctly. And I think we're done there. So we have a database factory that we can then call get database service on. It's going to expect the database service. So when we invoke, we pass it in here, and then the callback can do something with it. And the factory just literally invokes the actual call here, which is going to return a database service. So all very similar to the page factory. We now should be able to return a database service. That means then in here, we can now consume the database factory. And if you forget how to do it, you can see here is effectively, this is what we've got to do. We've got to bind to the function. And if we look at the page factory, it's this function here, because this is the injection. This is what the page factory is going to ask for from dependency injection, this function. So in our case, the database factory is going to ask for this function. So this is the one we need to do something with. And we want it to be a singleton. So add singleton database factory. So that's the database factory, and now we need the function that the factory is going to look for. So it seems like a hell of a lot of work, but this is all one time, and then it's all just going to work nicely for us. So I'll add a singleton that's going to return this. We'll have the service provider first, and then it's going to be a function that's just going to expect the x.getRequired service, and it's going to be a service of the database service, because there is no switching on this. It's just purely get the service it's after. What have I done wrong there? Cannot resolve singleton of that. What have I done? There's literally nothing wrong with that. Okay, let's explicitly pass a method back. That's gone. Now it tells me to go back to what it was doing. And now the error's gone. Yeah, this IntelliSense rider lately is crazy. So I think that's now it. We've injected the actual entity framework core database context. So we can pull that in for the database service. The database service is the thing we want to mask the entity framework raw calls with to be nicer. So we can do things like just get settings. And then we need to serve this up as a transient. So if this was fine and everything consuming it was a transient, these two aren't even needed. You just literally request the database service, job's done. But because we'll have things that have singletons, like the main view model, we have to do these two things and this factory all just to basically serve up this as a transient inside of a singleton. That's basically the purpose of that. So with all of those done, this is database services. And now we're free to just ask for and request the database factory everywhere we need to call the database services at some point. So let's start with the settings page. We can now go into the constructor. We want the database factory. And import that, and then we'll store it as a private database factory underscore factory. Store it as that. And in fact, why have I called it factory? It should be database factory. So now we have access to the database factory everywhere we want. Because we actually want to use it right here, we could just not store it here, but we're probably going to consume it at some other point in the settings page, so we'll store it. And now we can pull in these location paths. So instead of doing this now, we can pull in the location paths as underscore factory dot get database service, and this is where we should really be consuming it as a using. So what we should do, in fact, that does lead it. Yeah, so yeah, that's the only thing. The consumer is going to have to dispose of these correctly, which is not the end of the world, but you'd have to do using var db context equals, and then pull in the service. So that now we're going to be disposing of the database service. That's the only caveat there. We're just going to make sure we consume it correctly. We can now call get settings, and this should get the settings question mark dot location paths. And then if it's blank, let's just for now put in, just so we know if it's blank or not. Again, this is just temporary code. No locations, we'll say. And then obviously when we save, this will get saved out, and then the no locations will actually be something. Or in fact, let's just do a new list of nothing, because that really is the correct thing to do. And then let's add some temporary, we'll make some dummy data when we start up so it gets saved to the database. So the last thing we need to do before this all should fully work is apply those migrations at some point when the application starts. So for that, we could do the main view model as a singleton, and the main view model kind of does define the application starting. So we probably want it inside the main view model, and mainly here. So I think that's where we'll do it for now. As well as the page factory, we're going to have now a database factory. And I'm not going to, actually, I will store it because we definitely will use it somewhere else. Right there at the top. Copy and paste, database factory. And then we'll set it in here. And you can kind of do this as well, but I'm not sure why I did that. Because, well, in one way yes, in one way no. The fact we have the database factory injected proves that we will have it, but I guess if we forget to do that, similar to the page factory, it's always injected. We've seen it being injected, so we know it's here. It's not, if we commented this out, you could still run the application. So this is kind of a double check in the top application. Do we have the services we're expecting? So probably a good check to leave in. Database factory equals database factory, throw name of database factory. Database service, that's wrong, that should be factory. There we go. And now, I guess in here, we can literally do the migration. So we'll do using var db context equals underscore database factory dot get database services, and then db context dot apply migration. So that's how we'll now do the code we've already run before. And what we'll do here, it's not going to get committed to the database, but we can, oh, in fact, why not? Let's just commit it. So we'll then say if db context dot get settings equals null, we'll apply some default settings. So to do remove temp code, we'll do db context dot settings. In fact, then let's quickly add into the settings data. No, the database service. Where we've got get settings, we'll just do get and set maybe, or get and save. I'll do get and save. So we'll do save settings, void, and you want settings data model. And for this case, we're just going to completely override the settings. That's as simple as it gets for now. We'll do context.settings, and then what we can do here to ensure we've always got one, because of this kind of unique situation where the settings always wants to be one, we will just say underscore context.settings. Well, it's telling us to do an update, which will do a comparison, which we kind of could do, but because this doesn't have, it does have an ID. Yeah, we don't want to really use the update because we could pull the specific settings, then update them, then send them back. But because we are having a single row in here, we're kind of ignoring the typical way we do this. And instead, we're just going to say settings.remove range context.settings.toArray. So this will literally remove all settings. We don't need the toArray. That'll enumerate and force it. This will pass it in and be a bit more efficient. We want to save the changes at some point. Commit. And then here we're just going to add the new settings back in. So this is not the way that most database calls will happen. You'd normally update specific rows, but because settings is going to be a wipe all and save all, we're just going to do this basically. So this will remove everything from the database and the settings, add the single new one, and then save it. So that's how that's going to work. That brings us back to here now. We can just call save settings. We can pass in a new settings. And this is where we can now do a little bit of temp code to set some settings. So this will now be initial path 1. And this is just so we know it's coming from the database. Initial path 2, initial path 3. And that will automatically commit to the database. And then when the settings page view model consumes it, pulls it out and asks for the settings, it should now have those settings. So if everything went to plan there and I've made no mistakes, this should just work. And of course it doesn't. This is now the design time view model is now expecting dependencies of a database factory, which obviously this is design time, so it doesn't matter too much. We'll just make a new database factory. This is then expecting a new function, so we'll just quickly make that and return a new service. That's expecting a new application context, and we'll do that. So there we go. So this is what the dependency injection is doing for us. All this magic here is what we would typically have to do everywhere we're trying to inject dependencies. So that's the benefit of it. So if we run now, Now we get this issue because we haven't set the ID, and in here we'd have to obviously set an ID. So we don't have to do it for every time we create a new settings model. There's a few ways to do it. SQL Server has built-in things where the server can generate IDs, but SQLite doesn't. We could inject methods into the server to allow that, but just for quickness and ease for now, we'll just make a default value, which can just be GUID.newGUID.toString, and then we'll do this. As we expand, we'll probably move this into a helper, and we might do something else, but for now, just for real simplicity and quickness, we'll just generate the ID inside the data model, and then if we fetch it back, we will override this. This will only run on constructor. It's now complaining that we have not nullable values of null, which is correct because thanks to C# 9 onwards, these shouldn't be nullable. So if we want them to be nullable, we can mark them as nullable. If not, we should give them a default value, which I'll do like that. And what else is it complaining about? Performance issues because of string length. Will that? No, it's not going to give us a prompt, so there's going to be max length. And then what's that now complaining about? Field member should be Pascal case. So it's reckoning it should be IP like that. So this is probably a good thing to limit anyway. In fact, yeah, PDME. And I think that's a valid thing to do. Save that to dictionary. Location paths is uninitialized, so we could do the same thing there. Make the list always initialized. And that should then get us going. This should now hopefully run and save some default settings. And now let's just check if we have the value. There we go. So we have an ID. We have the initial values. So the database is good. Now do we have, oh yeah, there they are, initial path 1, 2, and 3. So that's now pulling from the database and saving. And that's the bulk of the work done now integrating Entity Framework into dependency injection. So you can see it's quite a lot of work initially, but now going forward, we can really easily inject this into all the pages and get and save all the settings by just adding nice simple functions here.